Hello friends, welcome back to my YouTube channel. In this video, we are going to discuss the reflection design pattern. Means here we'll talk about what is reflection design pattern, why it is important, and how it is used in real world systems. So without wasting any time, let's get started. So reflection design patterns. So reflection design pattern is a reflection agent is an AI agent that can look at its own works, judge how good that work is, and change how it is think or act to improve the outcomes. Okay, so unlike a normal agents that just follow instruction once, the reflection agent has a feedback loop like like act, observe, evaluate, improve, and act against. So this makes it closer to human problem solving. So for human problem solving, so it first is monitor the behavior and decisions. So what is mean? So the agent keeps track of what action is to took, what input is used, what output is produced, and what tools or data source it is relied on. So it is self-aware at the process level, not conscious but aware of step taken. For example, imagine an agent answering. Um, so my prompt is explain RAG versus fine tune. So the agent monitor which document is retrieved, whether it is used example, the structure of the explanation, the reasoning path used to generate the answer. Without monitoring, the agent would don't know how it is to arrive at that answer. So next steps. So check the how to evaluate the effectiveness. It what is mean now. After producing output, the agent judge it on against a predefined criteria such as accuracy, completeness, relevancy, and logical consistency, and alignment with the user intent. Okay, so these are the reflections where we are talking about these things. So what is the core components of reflection in agentic design patterns? So the first is action layer. So action layer it performs the main task that that is information retrieval, generating reports. And second one is observation layer. It monitors results of actions and environment's feedback. Next is evaluation layer. It accesses quality of actions against goal of KPIs. It's measure the completeness, accuracy, or clarity of the summary. Next is reflection layer. It adjusts the reasoning or strategy based on the evaluations. Next is a learning layer. This is optional. It stores the reflection for the future decision. Right. So a reflection agent is an AI agent that observes its own action, evaluates their quality, and improves its reasoning dynamically, and makes it more reliable, accurate, and intelligent over the time. So why use reflection in agentic AI? So reflection turns an AI agent for one shot responder into self-correcting, improving systems. Here are some benefits: are error reductions, mean it catch mistakes early. What happen without reflections? The agent generate an answer or takes an actions. So error, wrong facts, missing spelling, hallucinations goes unnoticed. And next is the mistakes propagates to downgrade the task and user performance. So how reflection helps here? So reflection agents check it on output before finalizing it. It asks a question like, is the fact whatever the fact is generated it is correct or not? Did I answer all the parts of the concern of the answer of the questions. Is there are any contradiction in my reasoning? Okay, so these things it will check it. So for example, in the rack systems, agent retrieve the outdated or irrelevant documents, and it generates the answer based on the partial data. Reflection steps detect the missing uh, creations or weak grounding. So agent retrieve more document and generate the answer. So as a result, the error are cows before the answer is to the user. So that are helping in error reductions. Second one, improve reasoning. This is a smarter problem solving. So what happened without reflections? So agent follow a fixed reasoning path. If a strategy is wrong, the outcome is poor. No opportunity to adjust midway. Right. But if I use with reflection, so reflection enables dynamic reasoning adaptations. So agent can change it uh, chain of thoughts, switch from solo to deeper reasoning, and breaks complex problem into a better sub steps. So in a system design task, what is the initial approach? So initial approach is too high level. Reflection identify lack of architectural depth, and agent switches to layer design approach like API, data, model, infra, and final solution is more structured and correct. Next is self improvement. It's learning from the past actions. So if we talk about without reflection, so even every easy task is treated independently. Past mistakes are repeated again and again. No memory or what worked well or pure or poorly. So how reflection helps here? So reflection create a learning signals, what strategies worked, what fails, what should be avoided in the next time. So these insights can be stored in long-term memory and used to update the prompts and used to select the better tools or agents. Right. Next thing, explainability. Again, what happened with the without reflections? So agent gives an answer with no justifications. So user can't trust or audit the decision. It is very hard to debug the failures. Okay, so these three problems will occur if I go with without reflections. So how reflection helps here? So reflection capture what actions were taken, why certain decisions were made, why alternatives were considered. So these can be exposed as a reasoning summary, audit log, decision traces. For example, in a financial or healthcare AI system, the agent explain the data source used, evaluation criteria applied, why the recommendation were chosen. So this build the trust, compliance, and debugability while using these reflection agents. Next is common reflection design. So reflection pattern define how often an agent evaluates and it improves its own work. Different patterns are used depending on task complexities, cost, and real reliabilities requirements. So the first step is that single step reflections. So the agent perform one round of self evaluation after generating an output. So the flow looks like execute it, evaluate, adjust, and return the results. So how it will work? So agents complete the task. Example, it generates the task, and reflection steps check the quality, the accuracy, com- uh, completeness, and clarity. If any issue are detected, the agent makes one corrections. This improved result it returns. Okay. Next is multi-step reflection, recursive. So the agent reflects multi times. It refining its reasoning in the loop until the quality criteria are met. So the flow looks like the plan, execute. First I start from plan, then execute it, then evaluate it, then reflect it, then replan, then execute it again, then evaluate it, and then finalize it. Okay, so for example, designing a scalable design Gen AI systems. This is the task I am just giving. So the first pass, it provide high level architecture, then reflection. It's too abstract, missing infra details. Second pass, add data pipeline and model serving, and the next reflection, lack failure handling is coming here. Third pass, add monitoring and fallback and evaluations. The next, the final, the final output is the production grade. And when to use this one? When we have the complex reasoning task, high and high stake outputs, designing, coding, research, there we can use this one. Next is collaborative reflections. So multiple agent evaluates and reflects together, each from a different perspectives, like how the flow looks like. So agent A is a generator, agent B is a critic, and agent C is the domain expert. Means agent A, generator, who send the data to agent B for the critic, and critic is sending the data to agent C, who are the domain expert, and then the domain expert agent C is sending the data to the shared reflection to improve output. Right. So this is about the collaborative reflections. And then next is reflection pattern in the RAG systems. So a standard RAG system retrieve the documents and generate an answer. A reflection enabled RAG system adds self-evaluation and corrections, which makes the output far more accurate and trustworthy. So imagine a RAG-based question answering agent. So first is the retrieve, pull. So pull document from the vector database. So the user asks a question, the system converts the question into the embedding, and it retrieves the most relevant document from the vector database, either ChromaDB, Pinecode, FICE. Second one, generate. So from answering using the LLMs. So LLM receive the user question, retrieved a document as a context, and it generates a natural language answers. Okay. So RAG use external document as a inference time while fine tune, modify models and weights. So limitation without reflections. Okay, how it will works here. So answer may be miss important differences and overgeneralize it here. Okay, next is evaluate it. So a reflection step evaluate the generated answer. Means is every claim supported by retrieved documents, ask any point missing, is the answer aligned with the questions. So this can be done the same LLM, self critics, a separate evaluator agent, a rule based check. Next is reflects and agents. So based on the evaluation feedback, the agent adapts the retrieval additional document, change search query, re-rank result, re-prompt the LLM with clear instructions. And then final answer. Finally, it return the verified and refined outputs. So the LLM regenerate the answers using the improved context. The output is now more complete, better grounded, and less prone of to hallucinate. So if we talk about like end-to-end flow here in this very simple way, so when the user is questioning with the with the user query, it retrieves the documents, and then it goes to the generate the answer, and then it reflect and evaluate it, and then adjust the retrieval and prompts, and then regenerate it, and then the final verified answer is coming. So this is the architectural view of reflection agentic design patterns. So reflection enable RAG system architectures. So this diagram shows a RAG retrieval augment generation system enhanced with a reflection agents. Instead of answering in a single pass, the system checks its own answer, fix problem, and then respond it. So here we'll see the step-by-step flow executions. So the flow is start with the user query. The user asks a questions, explain RAG versus fine tuning. So this is the trigger that start the entire agentic workflow. The query defines what knowledge needs to be retrieved and generated. Then it goes to the document retrieval, that is the vector database. So the user query is converted into the embedding. The system search a vector database, Pinecode, FICE, ChromaDB, and retrieved documents are retrieved. I mean, relevant documents are retrieved. So what is the purpose here? It's ground the system in the external and factual knowledge. And it reduces the hallucinations by avoiding the pure model memory. So what is the flow here? User query, retrieve document, and vector database. User query, retrieve document retrieval, and vector database. Next is answer generation, that is based on LLM. So LLM receives the user query, it retrieves the document as a context, and it generates an initial answer. That answer is not final. It's maybe incomplete, solo, or partial incomplete. So the flow looks like uh, the retrieve document from user query, document retrieval, vector database, and then LLM, and generate the initial answer. Okay, so a reflection layer evaluates. Next is reflection and evaluation layer here. So a reflection layer evaluates the generated answer by asking, are the claims supported by retrieval documents? Is any information are missing? Is there any hallucination or inconsistency? Does the answer fully match the user intent? So this kind of questions are asking here by the reflections. So how it works? So it can be done the same. The LLM self critiques, a separate evaluator, and rule based checks. Okay, so these are the labels. These are labels like hallucination, missing information, and inconsistency. So this is reflections and evaluation. This is the quality gate of the systems where these kind of informations are handling. Next is adjust and refinement. So if issue are found, the system adapt it. Okay, system will adapt. And what adapts? So it reformulate the prompt, retrieve the additional or more specific document, and is change the retrieval strategy, like top K filters is will do here, and improve the reasoning instructions here. So what is the key idea here? The system does not accept the failure. It's look back to the improve itself. Okay, it is a self-corrected correcting loop here. Next is the final verified answer. So the LLM regenerates the answer using improved context. The output is more complete, better grounded, more reliable, and uh, and then finally what the user see, only the final verified answer is written. Reflection steps may be stay in internally, we will not see, user will not see. Okay, so how this architecture we'll see it at high level. So first is the user query, and then document retrieval, then LLM generate initial answer, and then reflection and evaluations, and then adjusted and refinement, and then final verified answer. So this is all about the architectural design. Next is the example. So this is the example. So this program demonstrates the reflection enabled RAG pipeline where the agent is retrieved knowledge, generate an answer, evaluate itself, and improve the answer, and return a refined results. So this is the class vector db class. Okay, so this class simulates a vector database like pinecode, files, or chroma, and it accepts the user query, and it returns the relevant documents. See, these are the returns, right? And here, what is the key points here? So this is the retrieval steps in the RAG, and it provides the grounded context for the LLM, and it prevents the hallucination by supplying the external sources. Next thing, LLM. This is for generation and plus reflections. So this class represents the large language model that responsible for both generating the answer and reflecting, self-evaluating for on those answers. This is for generate method. It generate an answer using prompt and retrieve documents, and this is the returns. This is the evaluate method. This is the reflections. This model checks its own output against the quality criteria, right? And here I'm checking the criteria here, and then this reflection agent agent, it's act as an orchestrator. So this class coordinate the entire workflow and having some initializations, then initialization to initialize to initialize and retrieval and generation of the components. Then we have the retriever to retrieve document retrieval. Then we have the wrapper also to generate, and this is for modify the agent strategy based on the reflection based. If there is an issue, then we are using, right, a query plus is equal to example cost here. So this is the adaptive reasoning, and the agent change how it query and thinks. Reflections directly influence the future actions, and this is the run method. This method execute the entire reflection loops. Okay, and again this is for the retriever, retrieve the relevant document, and then this is the evaluation that will evaluate it. Agent inspect its own output, and this is reflect and adjust. The agent rephrase its query, retrieve better context, regenerate a more complete answer. This is a single step reflections, and this is our main class where we can call our reflection agents. So if I run it, so see here what we are passing here: explain, drag versus fine tune. So I'm getting this one. This is the retrieve document, this is the initial answer, and this is the reflection issues. This is the issue and final answer. If I change this if I change this context, um, so let's see what. Let's see. Okay, so this is the retrieve document, and this is the final answer I'm getting. Okay, so this code so how a reflection agent turn a simple RAG pipeline into a self-correcting systems by evaluating its own output and adapting its strategy before responding. So that's all for today. If this video helped you to understand the reflection design pattern, don't forget to like, subscribe and share. See you in next one. Thank you.